Right school. All righty then. Did you see all these stupid classes here? Yeah. Statistics. All right, looks like we were over here. Let's finish off this thing and then finish the next one. And then possibly start the next one. All right? That's the plan for today. Oh, excuse me. The most important news that I neglected to mention. So I believe you should have just received this announcement. The test prep and exam. All right, let's say test prep and exam for exam one, I should have said. All right, anyway. But the test prep and the exam should be available as of now. All right. The test prep is called a quiz on my math lab. All right. The quiz, the only difference with these questions and the previous questions is effectively now you're no longer going to have all of the help you stuff. Does that make sense? It's not going to give you the example. It's not going to link you to the textbook. It's not going to do any of that stuff. Does that make sense? The quiz has no time limit on it. You can take it as many times as you want. Does that understand what I'm saying? The exam can only be taken once. All right. The quiz, you can go back to it. You can start working and then you can come back to it. You can shut off your computer and whatever. Save for later. All right. The exam is not going to work like that. The exam has a time limit. The exam has a time limit of an hour and 20 minutes. All right. It's estimated on the exam currently when I just made it that it says it should be able to be completed in 45 minutes. All right. So I kind of just look at that and just start saying, hey, if I make it 2 hours, probably should be okay. Does that make sense? All right. You will have access to the computer during the exam. The reason why I want this to be this way is because, well, first of all, I want you to be able to use the calculator, all right, while we're doing this, all right? So I would just take the numbers and just type them in, all right? But for those of you who don't have the calculator yet, you'll be able to use the StatCrunch program on the software as well, all right? So you can copy the questions into StatCrunch. We're not really going to be having that much data that you're ever going to be having to type in. It might be a maximum of like 20 numbers or something like that. So just remember that's annoying, but make sure to check your work to see that you actually type those numbers in correctly. Does that understand what I'm saying? The quiz is created as preparation for the exam. Does that understand what I'm saying? The only thing is they're both variable in terms of which questions they give you. So no matter when you take it, you're not going to get the same questions. Does that understand what I'm saying? All right. But if you happen to do the quiz a couple times, I think there's a very strong chance you'll see a majority of the questions on your exam. Does that understand what I'm saying? You understand? All right. You will not be able to see your test results until the due date actually occurs. All right. You will not be able to review your individual exams, just only get your score. Does that understand what I'm saying? But I'm telling you, the quiz is almost identical. Does that understand what I'm saying? The only difference is I don't know which questions you're getting. So there's so many combinations that it's, does that make sense? Yeah. Oh, wait, 1 second. The quiz counts as a grade. All right. The quiz scores count as 50% of your homework grade. Does that understand what I'm saying? So, like, whatever homework you've done so far, that quiz that you're about to take pretty much counts as much as that homework in terms of your overall grade. Does that make sense? Whatever homework I've assigned to you, I should say. Also, another thing. Students sometimes sit here and go into my math lab, and my math lab will sit there and, like, let's say you don't attempt an assignment, right? Here, I'll show you right now. Like, I don't know if other teachers even pay attention sometimes to this thing, but they don't always have to when it comes to um, D2L or whatever. Like D2L actually resolves this issue partially. So you can see your grades in D2L, and then you'll see the appropriate score in there anyway. Does that make sense? But if you go in your MyMathLab gradebook, ah, this managing completes. You ever see this? If I click managing completes, these are the assignments that I've already assigned so far. Does everybody see that? If I go over here, it'll start telling me 3 people didn't do this one, 4 people didn't do this one, 2, 5, 5, 7, 7, 8, whatever. Does everybody see that? And then I go like this. Select all past due, excuse me. These are all due. Submit scores. Now, I probably won't do this because your scores are going to be on D2L anyway. But if you go on your MyMathLab, it's going to sit there and say, if you attempted one assignment, it's going to tell you have 100% as your average. It's not going to give you zeros for the other ones until I just did. Does that make sense? So don't go in there and start telling me your MyMathLab gradebook says you have 100% and you didn't do any of the assignments. You expect to get 100%. All right? Because that's not going to happen. All right. I did reopen all of the assignments just now. And they are now all due, or the due dates are not changed, but you can still actually change your score without receiving a penalty up until the date the exam is due. There will be new assignments on there as well for the next chapter, because I'm not really supposed to be giving you a week to do this test. Does that understand what I'm saying? I'm really supposed to be doing it in class today. Does that make sense? But I don't want to do that. All right? Does everybody understand? Question? Sorry, you had a question. Yeah, I got to put them in. The whole thing isn't connected correctly because of there's just a lot of stuff that has to be done on this stupid thing, and they only told us, like, let's say the days classes started of the semester that these new changes had occurred, and so everything I created previously has to sort of be updated a little bit. Probably this week sometime I'll try and update everything so that you can see all of it and it just automatically is syncing and all that stuff. But I have to reconnect them all one by one. It's not going to take that long, but it's very tedious. You know what I mean? Like, but I'll fix that. If they ever have an issue like that, just email me. But but that's the reason why. All right. Okay. So we talked about standard deviation before. It says find the standard deviations of the given sample data here, right? So I'm just going to do this real quick. Now, again, I taught you supposedly to be using La Calculadora, right? Not this program. I taught you to use, or I want you to be using the calculator. I think that it's much simpler to do it that way. I think it's more important. I think it's going to help you more later if you ever have to do the same. All right. Which again, I hope you do. It's so big. All right. So this thing sends here, find the standard deviation of this thing. So, well, I see some data. The minute I see data, I just immediately, when we start doing anything in statistics, I just start typing it in, right? So then this is 299. Oops, don't do that. Don't type the wrong number. 299, 287, 276, 266, 218, 226, 268, 227, 198, right? Now this stuff here, it says find the standard deviation. Well, again, really, we've only really talked about how to do one thing really on here, and that's use, what's the name of the function? No, what's the name of the function that we talked about? What'd you say? One var stats, all right? So then this one variable statistics, right? If I click stat calc here, one var stats, and then I give it L3 here, right? And then it tells me this. Does that make sense? Which one's the answer here? I'm not kidding. You're gonna fail if this is gonna stay like this. You can't keep telling me you don't remember what we did in the last class. Does that understand what I'm saying? Because it's not gonna work soon because you're not gonna understand the next thing. So, does that make sense? How do we answer the question? What does this thing mean? What's the first one? What does that mean? That's the average. What does this mean? Sum of the x values, just add these up, right? What's this mean? Yeah, if you squared all of them, you added that up. Does that make sense? You're not gonna need that really. What's this? So if you know what it is, why don't you tell me the answer? How? What do you mean? You got it written on your paper. So that you're looking at the right page. You're telling me the answer, right? You're correct. There's nothing. What else is there? Does that make sense? What I'm saying? But this sample, and then it says S, right? And then you're telling me sample standard deviation. It's like, well, if they're going to name it something, they probably name it S. Does that make sense? And then I told you that. What's this one? Do you remember what this one is? This is the population standard deviation. They call that sigma. Does that make sense? As long as you just know what the difference is, you're fine. Does that make sense? But you got to pick the right one. And then you also have to, sorry. How, you got to pick the right one and you got to know which one is for what thing, right? Now, this is another thing I got a problem with. All you got to do is type the stuff in, right? And then read it off of here. Is that correct? All right, so you have to know how to do that. But when do you use the first one? When do you use the second one? What in the question would tell me when to use this one and when to use this one? What would you say? 1 second, just raise your hand. Apologies. But that's true. But the thing is sometimes they're not gonna just say what is the sample standard deviation, right? So then what would you have to do? You'd have to recognize whether the thing that they're talking about is either a sample or a population. Is that correct? How do you do that? You need to know what the words mean, right? That's what we did the first day. Does that make sense? All right. So but my point is that I don't even believe a bunch of you guys if you tell me you don't know what those words mean at this point. I really don't. Like I bet if you sat there and you thought about it for a couple seconds, I bet you probably actually know. All right. I'm not kidding. I wouldn't say this. Does that understand what I'm saying? All right. But this is showing me though that you need to go through it again. Does that understand what I'm saying? All right. And do not just start taking the review quiz and then start taking the test and try to memorize because I'm telling you, then the next test you're gonna flunk it. Because the stuff's not going away. Does that understand what I'm saying? All right. And then the final we have to do, right? And the final, it's harder to put it all together at the same time if you're not remembering things from beforehand. If you are remembering things from beforehand, it's actually much easier. Does that make sense? Usually I'll get a lot of scores get the highest grades. A lot of students get their highest grade. All right. But there are some issues here. Does that understand what I'm saying? You need to review. Okay. All right. So this was another thing I talked about last time. Variance. Does anyone remember what that was? I said I'm going to ask you on your exam. But again, like these are very simple things. But if I don't remember what the word means, there's no way I'm answering the question, right? Correct. Does that make sense? So find the variance of given data. Round your answer to one decimal place. The weights in ounces of 10 cookies are shown, right? Now the question we have to ask ourselves is this a population or is this a sample? Does that make sense? What would you say? I would actually say sample. Because I don't think these are all the cookies that have ever been made in the entire world. Maybe they are, but it's not clear. Does that make sense? And if a student argued that to me, I would give them points. Does that make sense? Because I think they're right then. Does that make sense? All right. If you tried to argue this is a population to me, I'd be like, why are there only 10 cookies? You know what I mean? Does that make sense? Now, if you tell me these are grandma's special baked new cookies, she's never made them before. She made a batch of whatever at 3 p.m. today. You should smell them. They're really good. Here's the weights. That's every one of grandma's cookies then, right? Does that make sense what I'm saying? All right, but you got to read the question to see that. Does that make sense? This one's not the clearest. All right. Does that make sense? All right. So all you would do is type these numbers in, right? Then do one var stats. Does that make sense? Why don't you do that right now, actually? Why don't you type them in, do one var stats, and then tell me what you end up getting for the variance. Does that make sense? Yeah. Because I'm telling you, if you get used to using the calculator, you'll tell me it's not bad. If you don't get used to using the calculator, you'll tell me I'm using all these formulas. The person in the math lab was teaching me all these formulas. They don't know what the hell they're talking about. And I'll turn around and I'll be like, that's not the way I told you. Does that make sense? And I'll be like, and then I'll explain it to you, and then you'll turn around to me and you'll be like, I have no idea why I'm trying to do this. 0.150 is correct. That's what I got. All right. So, I mean, I just typed it in, and then afterwards, when I had done one var stats, I just typed these numbers into, whoops. I typed these numbers here in this list here, 0.62, 1.4, 0.63, whatever. That takes about, 15 seconds or something like that, right? Then you type that in. Then after that, you get calc, one var stats. Then I just did this for L3. Then I used SX here. Does everybody see that? Right? I just said 0.38767, I believe. And I somehow deleted this. Oh, I guess I should teach you some things on how to use the calculator. So if you click second entry here, it's going to let you start going back to your previous responses. Does everybody see that? If you click second entry and then you push up, it'll let you go back to all the previous things you just typed. Does that make sense? All calculators work like this. Even the regular scientifics, they all work like this. All right. So you don't have to keep typing the same crap over and over and over again if you don't want to. Does that make sense? All right. So I just go back here. I grab this one again. And I delete this because this is not supposed to be here. That's what I had said before. This is the answer I got. Does that make sense? This is one more decimal place in the original thing. So one more decimal place would mean it's going to be to the thousandths digit. So that's 0.1502 makes this round down. Does that make sense? Question? Joel, question? Test scores of 40 students, find the standard deviation. All right, this crap. This garbage. All right. You don't get this stuff right. No, you gotta get this shit right. Okay? Because it's gonna be on all your goddamn tests. And then not only that, they're gonna keep giving you more of these things. Excuse me. They're gonna keep giving you more of these things in the next chapter, and the next chapter, and the next chapter. All right? And it's going to be the same thing over and over and over again. All you're going to do is use this one bar stats. And I'm going to look at it and we're going to talk about it. And I'm going to be like, how do you do this? And I'm going to be like, I'm not going to explain it. How do you do it? And you guys are going to turn around and tell me one bar stats. Does that make sense? All right. But now's the time to be able to do it. Does everyone understand? All right. Very, very, very easy. All you have to do is remember that the calculator requires us to be able to say XIFI. We have to write something in the form of frequency distribution. Does that make sense? Then I'm just going to type this into L1 and type this into L2 or whatever, and then do one var stats L1, L2. Does that make sense? Where L1 is the list of values, and this is we called it before, I was being silly, but I kept saying freak list. Does that make sense? Right? But I'm serious. These dumb things, you say this crap in your head, you'll remember it. You'll be like, oh, freak list. Yeah, that's the list of frequencies. Does that make sense what I'm saying? But otherwise, if you don't think about it, later on, you'll start taking your test, and then you'll get to that screen, and you'll be like, oh, I don't know what to write. I haven't been writing anything in there. Does that make sense? If you just ask yourself, you will remember. All right? Okay. So you're going to explain me because I already went over this before. I didn't say standard deviation, but I taught you how to write the list. What do I need to put in L1? What do I need to put in L2? Bad. You made a mistake. Big mistake, though. Why is 50 no good? Oh, you're saying there's like type 50 and all that stuff and then 59 here? Is that what you're saying? Okay, then what? That's the only part where you're gonna actually do something. No, but remember what value means and frequency means, right? So we need values, right? Values of what? Values of the scores is correct. If they sit here and start saying standard deviation, they're definitely talking about the standard deviation of the scores of the people that were taking the test. Does that make sense? Or the average score of the people taking the test. Is that correct? I'm not interested in the standard deviation of frequencies. How much variation is occurring in these numbers based off these particular classes? That's like useless. Does that make sense? All right. So this first class, what value do we pick? The average, right? What number is that? Say one time. 54.5. Okay, but you see, this is the problem with people just paying attention to their calculator too much. Does that make sense? Because you're gonna probably just type that in, right? If I type that in here and then I go run one var stats on it, and you don't think about these numbers at all, like what this means or anything about like what's going on here, and you type that answer into the test, guaranteed it's wrong. Does that make sense? Because the problem is that if I take this stuff and start typing it in here, and just to make a mistake typing it in, which is quite possible. Does that make sense what I'm saying? Then it's going to give me the wrong answer, right? But this says 50 to 59. I better pick a number between 50 and 59. Is that correct? Right? So if you do something like that, whatever, if you just read it, you'll be like, oh, I picked the wrong number. Well, shoot, I got to think about it for a second. Does that make sense? All right. But don't, I always tell this to students, don't just blindly, oops, maybe actually like stop talking, but don't just blindly start typing in numbers and then assume you type them all right. You'll see me typing these things in. I'm going to make mistake after mistake after mistake and constantly correct it. Does that make sense? Don't assume you've typed everything correctly. Does that make sense? All right. Assume you've made a mistake instead. Does that make sense? Pretend like it really matters typing these things in, and you're not going to get paid otherwise if the answer is not right. Does that make sense? All right. Because sometimes that's the way it is for me. All right. So my point is that you type these things in, you get some crazy answer. Let's say I start saying that the standard deviation is, I don't know, 1,000. The numbers aren't even between the numbers aren't even have a difference of 1,000. Does that make sense what I'm saying? Let's say I got a really, really, really small standard deviation, 3. These numbers are varying between 50 and 100. They're not spread out by 3. Does that make sense what I'm saying? All right. Anyway, type this crap in, And then literally, now it says the test scores of 40 students are summarized in the given frequency distribution below. Find the standard deviation. Now, I cannot tell if this is population or it is sample based off this. Does that make sense? I would have to assume sample because, again, they haven't explicitly stated it's the population. Does that make sense? Calculate this. I type this now in L1 and L2 here. And then I would just report this number here. Does that make sense? 13.625, whatever. Does that make sense? Question? Anybody? So box plots. Let me see if I can remember how to do this in the calculator. I think you go to second stat plot, then you click. You have to turn plot 1 on. Then you click this picture. Then my list is values. See, it says X also again. X meaning values. Does that make sense? Right, I wrote XI, FI, right? Then frequency was in L2. Does everybody see that? So all I did was click second Y equals here, and I got stat plot right there. Does everybody see that? All right. Now, if I push enter, and then I push graph here, I believe. Does everybody see that? Nope, made a mistake because I have this garbage in here. Let's try that again. Nope. Zoom 9 stat. There we go. All right, make the picture. Well, first we got to explain what this picture actually means. All right. So what typically a lot of software will do is the first thing you do is you type in the numbers, then it'll sit there and it'll be able to calculate all those descriptive statistics they refer to them as. The median, the mean, the mode. And then we're going to talk about a couple more today. The minimum, the maximum, and then we're going to talk about the quartiles and the percentiles also. All right. But it starts trying to give you an idea of sort of the distribution of the data. Does that make sense? Like where the median tells you where 50% of the data is less than it and 50% of the data is greater than it. Does that make sense? All right. So then if I give you all these numbers, right, it sits here and it does this for me. And we did it a couple seconds ago. We just did this with one of our stats. We typed it here. It spit out all these numbers. Does everybody see that? These numbers are good. Okay, they really are. Like if you sit there and you stare at them for a couple seconds, you just think about what they mean. You'll be like, and you should try this sometimes, all right, to try and think about it because then it'll make it easier when you're taking your exam. But you're like, what does this stuff mean about the data set? Does that make sense what I'm saying? Is it more lopsided to the left? Is it more lopsided to the right? Does it seem fairly symmetric? Does it seem like it's got a big average? Does it seem like it has a small mean in it? Or the average is really different from the median, like stuff like that. Like these types of things, they can tell you a lot of information about what's going on. Does that make sense? All right. So so that's why they calculate that, right? So it'll spit this crap out pretty much every single computer program you can imagine. Does that make sense? Just like descriptive statistics somehow. Does that make sense? So that's why they're doing it here. Okay. Now, if I do it here, though, then there are these numbers here at the bottom. This is called the 5-number summary. So there's something they refer to as the 5-number summary, which this is typically the thing that the programs will give you. Does that make sense? The 5-number summary is they call this an ordered tuple, not an ordered pair. Pair is just 2 numbers. Tuple just means could be other than 2. Does that make sense? So then so then you take the minimum, something called Q1, the Q2, Q3, and then the maximum. And that's referred to as the 5-number summary. Okay? So we got to explain what Q1, Q2, and Q3 are. I think minimum and maximum is pretty obvious. Does that make sense? Right? All right. So the first thing we're going to talk about is, well, the median is the number that separates the lower 50% of the data and the upper 50% of the data. Does that make sense? Okay. That's also called P P50. Okay. It's also called, or could be called, I should say, Q2. These are all names of the same crap. Does that make sense? It's also called D5. We can name more names if we really have to. Okay. Yep. Why? Interesting question. No, it's not actually very interesting. So the thing is any data set, right? Obviously has some minimum and maximum value, right? And then the median doesn't necessarily like have to be over there. Let's say the median is over here. Does that make sense? The median has, though, 50% of the data should be over here. And the remaining 50% should be over there. Does that make sense? Or close to it. Because the thing is if this value is here, it's possible then you're not counting that one anymore. All right. Well, another way we could say this is like we could call this, we said P50, or this means the 50th percentile. Does that make sense? So if I start saying PN here, like this, you write a number there. Does that make sense? This means the nth percentile. Does that make sense? To determine the percentile of a data point in a sample, of size n you take the number of values less than x and you divide by n. Does that make sense? The percentage of stuff or the fraction of stuff less than it. Does that make sense what I'm saying? But the key thing to remember is less than. Okay? Does that understand what I'm saying? So in other words, like as an example, if your score is let's say equal to P80, then this means you scored greater than 80% of the test takers. Does that make sense? Obviously, 20% then scored better than you. Is that correct? Or thereabouts. All right? Could be a little less. All right, so then what they say is you can divide the entire data set into these percentiles. P0, P1, all the way up to whatever. All right, let's ask some questions. Can you be in the 100th percentile? What would you say? Based off the definition I just provided to you, can you be in the 100th percentile? So let's pretend like you say no. Why not? That's correct. Good. That's correct. So then the thing is this thing here, like if we start saying that you, I don't know, let's say there's 20 people in the class. All right. So let's say you got the best score. Right? How many values are less than your score? 19. What's the sample size though? 20. 19 out of 20 is 95%. Does that make sense what I'm saying? Means you'd be in the 95th percent. Is that correct? You ain't in the 100th percentile. Does that make sense? You could round up to the 100th percentile possibly, but that's only if someone was rounding it. Does that make sense? You can't be in the 100th percentile. You can't be better than yourself. Does that make sense? Does that make sense? Can you be in the 0th percentile then? I've seen multiple answers. There's only two answers to this question possible. I've seen them. Somebody explain me. If you say no, if you say yes, explain us. Good. If you're the worst grade in the class, then there's no one less than you. Is that correct? Right? So the number of values less than me would be 0. Is that correct? 0 divided by anything is 0. Does that make sense? So the answer is yes, you can, based off this definition. Does that make sense? Some places do define it differently. Some places do include the value also, like less than or equal to. Does that make sense? All right. Question? All right. So then some people like to use different numbers because if I start saying somebody's 67th percentile, honestly, most people don't understand what this means. Does that make sense? All right, that means you scored about more than 2/3 of the people. It doesn't mean you got 67 on your test, though, right? You could have gotten a freaking 5. You could have gotten a 99 also. Does that make sense? I have no idea. Does that make sense? Until you tell me some more scores, right, in their percentiles. Does that make sense? But what I could do is, so like, this is kind of weird, but like this right here is half the data, and then this is half the data. Is that correct? Right? And then, oh, why did I draw it like this? Yeah, whatever. All right, then if I split this like here, this would be like a quarter of the data, and this would be a quarter of the data. Is that correct? Half of a half, is that right? And then if I split this here, this would be a quarter of the data, and this would be a quarter of the data. Is that right? So then when you start talking about quarters, right? Like you know with change, right? Dimes, quarters, right? Dimes, they've broken it into 10 parts. Is that correct? Quarters is 4 parts, right? Pennies is 100 parts. Is that right? Well, pennies are like percentiles, right? Percent. Is that correct? So then deciles, what do you think that means? And then quartiles, what do you think these mean? They're going to break it up into quarters, right? Something with 25% is correct. And they're going to break it up into 10% or tenths. Does that make sense what I'm saying? Right? So then the thing is this here, we call this position right here Q1. This we call Q2, but again, that's the same thing really as the median or the 50th percentile. Does that make sense? Or if you wanted to call it D5 also, the 5th decile. Does that make sense? 50 cents. Is that correct? Does that make sense, guys? So then this is Q3. Does everybody see that? Q3 is the same thing as what percentile? 75. Q2 is therefore P25. Is that right? Does that make sense what I'm saying? And then I guess this have to be P0, right? Does that make sense? There isn't really, well, I guess you could call this Q0, but I don't think your book names that way. Does that make sense what I'm saying? All right. Question? Any question? It would then be like Q4, P100, stuff like that. But the problem is that's not really true. Because we just said that we never really get that though. Does that make sense? There isn't really, so like it depends on the data set, to be honest. All right. If I'm going to start calling it Q4 has to be the same thing as P100, right? P100 though is only going to be like, if I have like 999 data points and I divide this by 1,000, then you get 99.9%. Does that make sense? Technically, this is in P99.9. Does that make sense? But what if someone says, I don't want you to do 99.9. I want you to round to the nearest number. Then you would say this is P100. Does that make sense? Okay. So I'm just saying, like, technically, you're never actually in that 100th percentile because you can always express it as a decimal. Does that make sense what I'm saying? Question with this? Does everybody get what I mean by deciles and all this stuff, though? Does that make sense? All right. Now, when you read this, you'll be like, oh, yeah, fine. Okay. This is Q1, median, Q3. So if they ask you to calculate this stuff, you just type it in and you do the same function we've been talking about. Does that make sense? This answers every single one of your questions pretty much for the first chapter, for the first exam. Does that make sense? Q2 or P50, right? Or D5. Does that make sense? Question with us? We gotta do some examples though, all right? So then they give me this thing. Describe any similarities or differences between these two block plots. All right, whatever. So let's pretend there's some y-axis here. I have no idea what this is talking about. There's 2 data sets though, for sure. This is like sample 1, this is sample 2, let's say, or maybe they're, populations even or something like that. I don't know, but I would assume they're samples first unless somebody says otherwise, right? So then this value right here is the minimum for sample 1. This value is Q1 for sample 1. This value is Q2 for sample 1. Does that make sense? This value is Q3 for sample 1. This value is the maximum. Does that make sense? Generally, don't refer to Q0 and Q4 at all, right? Because of what I was saying before. Does that make sense? Not really. Because sometimes Q4 is the maximum, sometimes the maximum is not in Q4. I just gave you an example before when we talked about 19 people, right? or excuse me, there's 20 people taking the test and you got the highest score, right? And you scored better than 19 people. That's the 95th percentile. That's pretty far away from 100 now. Does that make sense what I'm saying? So then like but if someone said round to the nearest 10 or something, now you're back to 100 again. Does that make sense? So it just depends, okay? Here. But the reason why you would do something like this is because after I've calculated these numbers here, now I would easily be able to compare these two data sets. Does that make sense? This one seems like it has a median that's a little bit lower than this median. Is that correct? Does it make sense what I'm saying? Question, Chloe? All right. What do we have now? Just discuss the differences between Q1, Q2, Q3, the minimum value, the maximum value, and compare between the two data sets. So you're just supposed to visually look at the differences. Like this value and this value is pretty much the same, right? This value is not the same as this one, right? So 50% of the data here is less than this number, whereas 50% of the data for this one is less than that number. Does that make sense? Like the 25th percentile is set to the 50th percentile is between here and here for this one. It's between here and here for this one. 50% of this data is almost less than 25% of this. Q1 for this data set's larger or almost equal to 50% of the greater than 50% of the data in this set. Does that make sense? But you should be able to do that, I think. Does that make sense? All right. So now they start talking about so we did measures of center, we did measures of spread, and now this is measures of relative position. Percentiles are measures of relative position. They're measuring where the data point is compared to other data points. Does that make sense what I'm saying? All right. The next one they start talking about is this thing called Z-score. All right, Z-score is sometimes called standardized score, standardized results, standard score. Sometimes people call it standard, but that's kind of dumb. This thing I'm about to say. I'm going to stay. So there's been a few things that I've noticed that people have already been forgetting, which I am sometimes surprised about, sometimes not. I'm just trying to remind you. Does that make sense? This thing. This thing, you're going to forget what this means. And I'm going to get mad. Because we need it for this class. All right? And anyone is going to be able to understand this as long as you can subtract and divide, which I know you can. So you have to be able to understand what we're talking about. And then in addition to that, this is going to be used like every day in this class very soon. Does that understand what I'm saying? But this particular definition I'm about to describe, I'm going to say it in words, and then I'm going to say it with an equation. All right? You have to understand how the equation relates to the words. And if you could subtract and divide, then you can understand. Does that understand what I'm saying? And you have to know the formula. Does that understand what I'm saying? And be able to apply it. All right. So this is the part that's helpful to remember so you can remember what it means. The number of standard deviations away from the mean. Okay? Where negative means less than the mean. Positive means greater than the mean. Those things will be very obvious when we write the formula. But this statement here is helpful to remember. The number of standard deviations away from you. We are going to say it a million times. But when you forget, I'm going to be like, why? if this is the only damn thing I'm telling you to remember. Does that understand what I'm saying? Okay. And it's easy. So that's the other problem that I have. Because once you forget, then that means you didn't understand what we were doing. And then on top of that, you're telling me you can't subtract and divide. Does that make sense? Which I know is not true. For real. It's not. We all know that's not true. Does that understand what I'm saying? So don't convince yourself this is garbage. Does that understand what I'm saying? And if somebody starts saying this standardized score and stuff like that, you could see that this might be something that comes up pretty often. Does everybody understand? Also, all this crap is in your book directly. All right. You can always take pictures out of mine, but I'm just saying the book's actually a little better than what I'm writing. All right. So because it puts it in the boxes, and then when you're doing your homework and you click link to the textbook or you click example, it's there as well. Does that make sense what I'm saying? So don't think I'm saying anything special with my book. All right. But but if anyone wants to take pictures, please take pictures. The only thing is I strongly recommend to write it down instead, because you'd be surprised how much more often you'll remember if you do that. All right. All right. So Z-score. What is Z formula? Z. See, that was funny. Anyway, it's okay. It wasn't funny. So then Z is equal to, right? All right. What are we going to do now? X. Oh, we always use X in every formula because that math people boring. All right. So then this X, right? X here, but that's not the right thing. I need to write something else in 1 second. Actually, I don't want to do this. 1 second. Nah, I'm just wasting my time. Here. So this is X minus X bar divided by sigma right here. Does everybody see that? Recall sigma is the population standard deviation. Does that make sense? Okay. We talked about, though, what X minus X bar was previously. Do you guys remember? We spent a long time on that last class. Remember what I called it? What do we call X minus X bar? What would it be calculating if you did X minus X bar? What would it find? Right, how far away the X is from the mean. Is that correct? Right, we said the first day, we were like, oh, if you do A minus B, it tells you the distance between A and B. Is that correct? So then if you have X minus X bar, this has to tell me the distance between X and X bar. Is that correct? How far away it is from the center. Is that right? But this could be negative. Is that right? There's a lot of numbers that'll be less than the average. Is that right? When you subtract like this, you get negative then. Is that correct? Does that make sense? Less than the average? If you're less than the average and you subtract. I didn't say anything about percentage. Why do you say percentage? Percentage means we have to divide by something. Does that make sense? Average. Average. Does that make sense? Right. Correct. Okay. But then there's numbers in the sample that are going to be less than that, right? You remember what average means? So what does it mean? Well, no, median is different, but something like the middle. Does that make sense what I'm saying? Or center. Does that make sense? But like my point is if you're at the average, there's got to be some shit less than you, right? Unless everything's the same shit. Does that make sense? Right? You get what I mean by that? Okay. So then there's some number less than that, right? So if we take that number and we subtract the average from it, we would get negative. Is that correct? Right? Okay. Like if you say 50 is the average, and you get a 20, 20 minus 50, negative 30. Is that correct? So this could definitely be negative. No one remembers what this is called from last class. Ay, Dios. This is what this name of this thing was. I called it a deviation from the mean. We even wrote it down. Okay? Right? They use this word, standard deviation. Is that correct? Sort of like the sort of like something like the average deviation from the center, but instead we had to square everything. So it's the square root of the average of the squares. Does that make sense? This thing of the deviation, average square deviation. So this top part is really just the deviation from the mean, or the distance from the mean. Is that correct? So then if I take the distance from the mean and I divide it by the standard deviation, finding how many standard deviations the thing is away from the mean. Does that make sense? Does that make sense? Let me give you another example with numbers instead of using these stupid words. And you're going to tell me that if you can't do this shit, we got a problem. And then we're just using different words now, pretty much. Does that make sense? Because again, it's just subtracting and dividing. Does that make sense? All right, so let's say you go to work, all right, and you make $5 a day. All right. Let's say you started with 50 bucks, and now you're ending with 75. And I ask you, how many days have you worked? What's the answer? 5. 75 minus 50 would tell me how much money I've made. Is that correct? Or the deviation from 50. Is that right? Then we take that and we want to see how many $5 days fit in there. Is that correct? So we divide by 5, right? So we get cinco. Is that correct? This is the same calculation. Is that right? Does that make sense what I'm saying? This is the distance between two numbers on a number line, right? And then we had something of size 5, and we're seeing 1, 2, 3, 4, 5. How many times is it going to fit in there? Is that correct? So what's the difference here? So now all of a sudden we're saying there's an average somewhere. They're deciding to write some funny symbol or whatever, right? And then they wrote another thing here. We're calling it X because we don't know where the damn number is going to end up being. Does that make sense? So then there would exist a distance between these two things. We call this X, oops. We call this, or we say this is X minus X bar. Does that make sense? But if it's on the other side, it'd be negative. Is that correct? Then the standard deviation is something that's given to you based off of the overall population. This is a number. Does that make sense? So now we want to know how many times the standard deviation is going to fit in here. So I would divide it by sigma. Does that make sense? Now the thing is that when you have the population, we don't write X bar because we would know mu. Does that make sense? So then instead we write this, and then this is referred to as z-score. Does that make sense? Now, what is this for? What are you using this for? We're going to see some examples in a second. All right. But like I remember, I don't know, I used to watch football a lot. Now I don't watch anything. I don't know what I do. But when I was a kid, I used to watch football a lot. I remember this dude. Anybody watch football? You do? So none of you guys, nobody really watches football? This is not gonna be a good example then. But there was this guy, Richard Sherman. All right, Richard Sherman was a Super Bowl MVP, I believe, one year. When the Seahawks, I think, won the Super Bowl. And then he played for another team. He was pretty good there too. Pro Bowler every single year, which is like an all-star. Happened to graduate from Stanford University. Not such a bad school. Kind of impossible to get into practically. All right. Sometimes top 1, depending on which one you're looking at. All right. So but very good school. Very, very hard to get into. All right. So not only is the dude good at football, but he's a goddamn genius, probably, right? Excuse me again. But he, you know where he grew up? Compton, California. All right. And when I was a kid, people growing up in Compton, California, when he was growing up there, like it's bad now, but like Jesus, like it was so bad before. It's not even funny. All right, like it's not fair to what people were having to experience. Does that make sense? What I'm saying? Like even now, it's horrendous in certain places, but like before, it was just like you're gonna get shot. You know what I mean? Like it's just, I don't know. Anyway, so there was riots. When I was a kid, I still remember it was the first time I ever saw any riots and stuff like that. And there's just burning the whole all of Los Angeles, all of it. And it was just on the news every day. And the and then I remember this rapper I used to like, and he was rapping in this song, and I remember he sat there and he's talking about these Korean people in these store shops who were shooting these black kids. Okay. And because they were saying they robbed something in the store. They didn't rob anything. It was on film. Turned out they just shot some girl in the back. Okay. And we obviously have seen stuff like this recently also, and this stuff is always going to go on, unfortunately. But the thing is like, how the hell did they find Richard Sherman? How were they so right? How did they find someone who was so good at football and also so smart that he managed to do well in this stupid thing, happened to go with Super Bowl MVP and whatever? I mean, somebody did a good job, right? You know how many people apply to these schools? How the heck is that kid even going to be able to do anything coming from Compton? Seriously. What is he going to know? How to not get shot? Well, we know he knows how to not get shot, okay? But the thing is like, seriously, what is he going to know? They don't even send the police in there. You think I'm going to go teach? Not that I'm anything special, but who's going to go? Nobody. Does that understand what I'm saying? All right. So that kid did well because of his parents and because of him. And that's it. Maybe his brother or something. Does that make sense? Sister, whatever. Right? So the thing is the point that I'm trying to make is that it's hard to find a diamond in the rough, right? Not when you do statistics. That's all it's about. Does that understand what I'm saying? That's all you're ever looking for. Does that make sense? So what this does is, all right, so like I teach at a private school, okay? Every single kid in my class gets a perfect score on the SATs. All of them. Every single kid in my class gets a perfect score or a maximum score on their AP exam. I don't know if you know what these AP exams are, but you can take a class in high school and these score of 1 through 5 or something like that. And then if you get a 5 on it, then it counts for college. Does that make sense? All right. And the exams are actually harder than, well, some of them. They used to be. Now they're a lot easier, obviously. But they're some of them are hard. Okay. Some of these kids are smart. Some of them aren't really that smart, to be honest. But they work really hard. And they have tutors. And they have me standing over their neck all day long, like being like, no, you're going to do it. And I'm going to make you do it. And I'm really crazy. Like really crazy. Like this, it's a joy coming to Broward College, to be honest. I'm not kidding. Because over there, I'm a Nazi. I am a complete and utter taskmaster. You know what? You should know what I mean. I'm Jewish, my friend. So you think I would say I'm a Nazi? What do you think I am, Putin? So no, but seriously, like this is a phrase commonly used. Like people refer to someone who is, overbearing and on top of you constantly and won't leave you alone and all of this, right? This type of thing, right? So obviously it's a gross exaggeration, but I exaggerate a lot, obviously. Okay, so the thing is my point is though, I am on top of these kids like white on rice, sir. All right. And it's bad. Like, it's bad what I make them do. All right. I mean, I don't think the math teachers at this school are going to pass my test that I give to these kids. Actually, I know they won't. I give them the questions, they flunk them all the time. All right. So and I'm talking about people that have PhDs from really good universities. All right. Berkeley can't do the same questions just because of how annoying the questions I'm asking for. Now, I explain it to the teacher, they can do it, of course. Okay, but the first time I give it to them, no, they're gonna get it wrong. Does that make sense? It's bad. All right. So the thing is, and I'm telling you, these teachers, the ones I'm talking about, are actually smart. Know more math than I do. All right. So the at least with some stuff. So the thing is here though, how are you gonna find this Richard Sherman, right? Well, if I compare those kids at the private school to each other in my class, it's borderline impossible for one of them to look significantly better than the rest of them. They're all getting a perfect score on this SATs. Does that make sense? Right? All you can end up doing is looking bad. Is that correct? You didn't get a perfect score. Oh my God, you got a 1580. Oh my God, you're not going to get into college. It's not true, obviously. All right. So the point I'm trying to make though is that those kids or these private schools in Connecticut, these people pay like freaking $180,000 a year to send the kid there. Really, they just ship the kid off, aloha, you know. But they send these kids to these schools. These kids end up getting into Harvard, all these different places and stuff like that. Not all of them, obviously. Of course, there's a lot of kids that end up committing suicide in these places. Not with your parents all this time, right? Not with your family, right? So but the thing is if I go and do this type of calculation here with the kids at the private school, right? Let's say you got a 1600, and then the other kids, let's say the average is 1550. I mean, let's say the standard deviation is 10. No, let's say 20. This is still actually pretty large. All right, 2.5. Does that make sense? It's 2.5 standard deviations larger than the average in this case. If I claim that the average is 1550 and the standard deviation is 20. Does that make sense? Does that make sense? 2.5 standard deviations larger. Does that make sense? 1, 2, and then a half of another one. Does that make sense? All right. Now let's go for Richard Sherman. Now I don't know what Richard Sherman got as SATs, but I remember seeing his GPA one time. I don't remember the exact number anymore. I just remember how much better the dude did than everybody else. Okay? Because that's what matters. Does that make sense what I'm saying? Right? And if you didn't have the opportunity and you didn't have the tutors and all the garbage, right? But you still did pretty damn well and you beat the crap out of everybody else around you. That's more significant to me than the people that did it with the tutors. Does that make sense? No, it is. Shows you did it by yourself. Shows you're going to be able to do it later. Does that make sense? I see you doing it with tutor. Honestly, it means, oh, I haven't said this in this class before, but I used to work in the tutoring lab at the school here because I hate doing my office hours in my office because nobody ever shows up. So I used to just sit in the tutoring lab and I would just teach everybody. So I can't stand the tutors. Sometimes they don't know what they're talking about. So but sometimes there's some really good ones, obviously. So I used to sit there all the time and I would see these people who would come in every single day. And I'd help them every day. By like day 3, I realized they're going to fail. No matter what I do. Because they never do it by themselves. Does that make sense? So I started saying to people, I'm just like, if you sit here with me for an hour, you got to take this crap and do it at home for 3 hours. If we actually got done a significant amount of stuff. Does that make sense? Because if I'm explaining it to you, now for you to go apply it, if it took me an hour to explain it to you, right? Now for you to go to apply it, you're going to run into some issues at some point, right? I mean, 3 hours is possibly an exaggeration, obviously. But my point is, it's going to probably take an hour and a half, 2 hours, possibly definitely 3 hours. Does that make sense? Right? And I always tell everybody, if you did this, if you want to use the tutoring, fine. Just use it the right way. Go and then take whatever you just did and go do it again by yourself. Because it's extremely important for me to know if I'm going to be able to do it when I take the test, not if I understood it when the tutor was doing it. Does that make sense? Does everybody understand what I'm saying? But this is a problem with all of us. This is like, hey, there's assistance right there. I'm going to use it, right? And then why am I going to go practice again afterwards, right? Like, who's going to do that? Does that make sense what I'm saying? All right. So it's like everybody has this issue to some extent, or will at some point. Does that make sense? All right. I mean, your parents, right? They do all these things for you, and then eventually you have to do it yourself, right? But everybody wants to hold on to the parents helping me for a little while, right? It's the same thing, really. Does that make sense? Anyway, my point is though you can't do that, right? People always tell me like, oh, will you tutor me and stuff like that. Well, first of all, I'll help because that's my job, all right? But the second thing is, I mean, I charge people like $150, $200 an hour to tutor them. You know that? I straight up tell them, I'm like, it's not worth it. And they're like, no, it's worth it. I'm like, all right. I'm like, the only thing that's going to be worth it is if I sit here and explain this stuff to you, and then you turn around and you tell me you don't need my answer. That's the only thing that's going to be worth it. Does that make sense? Because if you tell me you need a tutor again, nope. That's not the way it's supposed to work. Does that make sense? Because then the next thing we get to, and the next thing we get to, you're going to need a tutor. You tell me you need a tutor. You tell me you need a tutor. Then you get to the job. What, you need a tutor? Good luck with that, right? Does everybody understand what I'm saying? So you can use tutoring for what? Oh, here's another thing. I saw these statistics about all this stuff about going to the tutoring lab, right? Students visit the tutoring lab one time throughout the semester. Grade increases dramatically. Only one time, though. So they take some course. They only come one time the entire semester for that course. Does that make sense? Student comes 2 times. Grade actually goes up even more. Student comes 3 times. Grade goes up even more. Once you get to that 4th or 5th time, there was a wide variety of students that actually had lower scores. Their grade actually went down. Because these were the people that actually would start coming all the time. Does that understand what I'm saying? All right? And that's okay, honestly. But you have to do it the right way. Does that understand? You just got to understand that you got to take it and do it by yourself. And that's going to be fine. Question? We haven't done one yet. I'm still trying to do the example. I was babbling like an idiot. But the thing is like, if you have, so this Richard Sherman thing, as I recall, the GPA in his school, I think, was somewhere around 2 point something. I can't recall, unfortunately, right now. All right. But it was like 2. I just remember the difference. It was like 2, let's say 2.3. Okay. And then for the average, then Richard Sherman's GPA was something like 3.4, I think, or something like that. All right. And then the majority of the students in this school, their standard deviation, they really weren't doing that terrible, but none of them were really doing very well. So then it was something like this. Does that make sense? Or like, I think it was like this. So then the thing is if I calculate the z-score for Richard Sherman, then all of a sudden this would be the value, 3.4, minus the average, 2.3, divided by 0.2. This is 1.1 divided by 0.2. This is 5.5. Does that make sense? It's 5.5 standard deviations away from the average. Larger. Does that make sense? So in other words, compared to his distribution, compared to how spread out the scores were at his school, he did that much better than the other kids. Does that make sense? These people did better also, but they're only a little bit better when I look at their number here. Does that make sense? This number is really kind of a lot different. Does that make sense? So that's an easy to see. You see that on the paper, you're like, whoa, you never see anything like that. Does that make sense? So you get to go to Stanford, right? Does that make sense? All right. Let's see an example. So which is better, a score of 92 on a test with a mean of 71, a standard deviation of 15, or a score of 688 with a mean of 493 and a standard deviation of 150? So we just calculate the individual z-scores. So how do I do the z-score on the first one? If I do it in my head before you, I'm going to get mad. I'm done. So what's the answer? You should be able to do this in your head. 92 minus 71 is 21, right? 21 divided by 15. Does that make sense? 3 goes into both of them, so it's like 7/5, which is 1.4. Does that make sense? Of course, I would just do it on my calculator, especially if I was taking an exam. But the point I'm trying to make is that you must think about the calculation. Otherwise, you really are not, you're not going to, you're going to make a mistake. Does that make sense? And the only way to know when you're making a mistake is to read the number, read the question, think if the number makes any sense in terms of the question. Does that make sense? All right, so then the next one is, does everybody get what I'm doing here? 1.3. Does everybody see that? So now compared to their schools, right? Let's pretend like they're two different schools. They're taking two different tests. Does everybody see that? This one got a 688. This one got a 92. Does that make sense? Is 688 better? I don't know. I got to see compared to their distribution. Does that make sense? Right? What if everybody got 688? That took the same test. Right? Does that make sense? Then others like you, people that went to your school, people that had your teacher. In terms of the standard deviation, in terms of how spread out the whole thing is. Like if this data is really spread out, right? Then like if I get a number over here, doesn't mean that much. Does that make sense? But if the data is like only spread out by this much, if I get a number over here, kind of means a lot because it shouldn't be happening very well. Does that make sense? So we're trying to see how far away it is in terms of the spread of the distribution. Does that make sense? You understand what I mean by variation? What's a good example? I can't think of an example where you have to see numbers that are varying a lot. But if you can think of any situation where you see numbers varying, I can explain how this would apply in that case. I just don't know an example where you would usually use this. But the previous example should make sense. All right. So now we have this 1.4, 1.3. So which score is better? Well, let's say 92. Does that make sense? For the first score. Does that make sense? But this is slightly better in terms of the people that took that test as compared to the people that took this test. Also, another reason why you would do this, right? Like you got a 688 on your test, I got a 92 on my test. Like, wouldn't you immediately just say the 688 is better? But like, even if you, but then I'd be like, can the person who got the 92 even get a 688? You know what I mean? Like what are we? We're not comparing apples to apples. Is that correct? Right. So the thing is like, this allows you to start comparing things from like different situations to each other. Does that make sense what I'm saying? So like, for instance, Babe Ruth, baseball player, right? Hit lots of home runs and stuff like that. If I start showing, the reason why I actually started getting into any of this crap was stupid sports statistics. All right. Because they start showing you statistics and I start looking at it and I'm like, I mean, I don't care as much about the numbers so much. It's just you start seeing some of these things, you're like, I can't believe how good some of these people are. You know what I mean? And like Babe Ruth, I remember he hit 60 home runs, I think in 1927 or something like that. All right. The next highest amount of home runs that someone hit like before that was like 30. The dude like doubled it. You know what I mean? Like you talk about these guys now and someone gets 60 something and someone else had 60 before. It's like, great, that's a lot. But like that guy got 30 more than anyone had ever gotten beforehand, like an whole season. Like it's crazy. You know what I mean? Wayne Gretzky in the NHL. I remember he scored over 200 points in one season. That's goals plus assists or something like that. All right. The next highest was like around 100. The dude was just on another level. You know what I mean? Like he taught people how to play hockey then. You know what I'm saying? So, but if I wanted to compare, let's say, Babe Ruth to a baseball player playing today, right? There's two ways you can compare them. You can compare them based off of how one is performing right now versus how the other performed then, and just say, hey, Babe Ruth hit 60 home runs. This guy's hitting 64. He's better, right? Or you can sit there and you can start saying, let's compare Babe Ruth to the players he was playing against. And let's compare the player today against the player he's playing against. Get their Z scores. Does that make sense? And compare their Z scores. Does that make sense? You're comparing them first to their own distributions. You understand what I'm saying? I don't know if that example helps a little. Does that make sense? All right. All right, find the percentile for the data value. Data value 6. So we said the definition for this previously. Said a little earlier today. Does anybody remember what the definition of percentile was? I said percentile of data value X. How do we determine what that is? Over N, what does N mean? Sample size is correct. Does that make sense? Average is the one with the bar. You said that earlier, right? But N, number, right? Math, N always means like how much the count of something is, like what number there is. Does that make sense? All right. So sample size. Does that make sense? Okay. So how am I going to do this one? No. Why do you say that? You just told me a definition. When did anything say anything about adding? And then that's the percentile? Then what? So that means you're telling me the percentile is going to be affected based off what your score was on the test? Just the score? So in other words, like if you got 100 or 1,000 or a 2,000 or a 3,000, even though you got the highest score on the test, your percentile is going to change? You said what the formula was, but you still haven't told me how to do it. Say the formula one more time. I see a bunch of people sitting here not doing anything. If you can read, you should be able to do this. The number of values less than X divided by N, which is the sample size is correct, right? The number of values less than X divided by the sample size. Okay, so what's the sample size? I have no idea why people are looking at their calculators. Seriously, I have no idea. Why are we looking at the calculator? 20. But seriously, I have no idea why people are looking at your calculators right now. Why are we looking at your calculator? Did what? Why? No. Bad idea. Terrible idea. Why would we do that? No, but I'm trying to explain something. Why would we do that? The only thing we talked about so far to put things in the list is we need to calculate all those statistics. Does that make sense? It didn't tell me percentile of data value, whatever. Does that make sense? So that's not going to help you. Does that make sense? The only thing you're going to get from that is you're going to be able to, it's going to be able to give you the sample size. Why am I not just counting them? Does that make sense what I'm saying? So she has the correct answer. There's 20. Is that right? Okay. 20 is not a percentile though, obviously, right? So we just said that the definition was what? The number of values less than X divided by total number of values. Is that correct? There's 20 total values, right? So how many, what would I have to put on the numerator then? What'd you say? How'd you get 7? Count out the number of values that are less than 6. Does that make sense? Because 6 is your score on the test. Is that correct? Right? Or that's the way I think about it. Because that's the only time I remember seeing these numbers all the time was when I was in school. We would take these standardized tests. They come back and they'd be like, "Oh, you're in the 88th percentile or something," right? And I was like, "What does that mean?" They're like, "Oh, you got 88% of better. You did score better than 80% of people that took the test." Well, what score did I get? Then they don't tell you, right? Does that make sense? So here, this data value, I don't know. Let's pretend that's my score. Is that correct? All right. So again, I just think of, so we were even calling these like P something, right? Before, is that correct? Percentage, right? Now it's not really percentage, it's percentile, but what does percentage mean? We talked about this earlier, right? Fraction. Is that right? So all this is to me is the fraction of stuff less than me. Does that make sense? So how much total stuff is there? 20. Is that correct? So then what's less than me? Now you see what I mean? I'm just like, you just count, right? So then 1, 2, 3, 4, 5, 6, 7, and that's it. So we get 7 out of 20. Is that right? Now I'm just saying, like, you can all sit there and do this in your head, right? So if you just say to yourself, well, if I think of this in terms of 100, right? Times perfect, multiply by 5. So you multiply by 5 on the bottom, you multiply by 5 on the top, therefore you get 35, therefore this is 0.35. Either that or just do this on your calculator. Does that make sense? But I'm just saying with some of them, it's like, yeah, you could do it in your head. Does that make sense? Now wait, 0.35, so then this means that P35 is 6, or we would just say 6 is in the 35th percentile. Does that make sense? Okay. Any question with this? Should be pretty straightforward. Does that make sense? But you got to remember the definition, right? Does that make sense? That's all this crap is in math all the time. They say to use some stupid definition, whatever they say, that's it. Always. Does that make sense? Hopefully. All right. But no, but some books change things slightly, is all my point is. Does that make sense what I'm saying? Like I could define it slightly differently if I wanted to. All right. Question? The test scores of 32 students listed below. Find Q3. All right, Q3. So the way I would do this is I would be like, well, Q3 just means, what does it mean again? Yeah, quartile 3 is correct, but I want you to start saying 75th percentile. Is it third quartile, right? 3/4. Does that make sense what I'm saying? 75% reminds me more of what it actually means. Don't get me wrong, you're saying the right thing though. So then there's 32 students, Q3. All right, well, I just remember before I said, it's quarters, right? How do you get a quarter? You take half of a half. Is that right? So then, like, you got half here, right? Then you do a quarter, then you would get like there and there. Does that make sense? All right. Well, they got to put the numbers nicely here. Like, we could just split the damn thing right there. Is that correct? So I don't want you to just tell me Q3. I want you to tell me all of them. What's Q1, what's Q2, and what's Q3 here? Because, I don't know which one of these I'm going to ask on the test. Does that make sense? I'm going to ask one of them, though, for sure. All right? Question? Small question? So how am I going to find it? What's Q2 first? Again, if you think of the definition, you're going to get it right. Okay? If you don't think of the definition, you might make a little error. Right? Q2 is the same thing as the median, is correct? What is the answer? Now I know also everybody's done mean, median, mode before. Does that understand what I'm saying? All right. So I don't even believe you. You tell me you don't know what this is. 68? No. Now, 68 is a bad answer. Okay. Why is it a bad answer is the important part, though. All right. This number does not have 50% of the numbers less than it and 50% of the numbers greater than it. We said that's what the median means. Is that correct? You get what I mean? If you keep focusing on the definition, you'll make sure you're doing it right. Does that make sense? Because just always ask yourself, yeah, does that satisfy the definition? Does that make sense? Right? Oh, maybe 68 is the answer. I don't know, right? Okay, 68 is no good. Does that make sense? What's the answer? 69.5 is correct, right? I even drew a line through here, right? To show you where it needs to be split. Is that correct? So then that would mean, though, it would have to be the number between these two numbers here, right? This is an even data set. Is that sample size is even? Does that make sense? The sample size is even, you're never going to split it to a number that's in the actual sample. Does that make sense? So then this is what? 69.5. We just take the midpoint or average between those two numbers. Is that right? Okay, so that wasn't that bad. Does that make sense? All right, how are we going to determine the other guys? What's Q? So we just said this was 69.5, right? What's Q1? No. No. 32 is like the minimum. 55.5 is correct. Quarter one, where is quarter one occurring? Well, right there. Is that correct? That should be the number between these two numbers. So that would be what? 55.5. Is that right? 55.5 is the number that separates the lower 25% from the upper 75%. Is that correct? Or the lower quarter from the upper 3/4. Does that make sense? Question, anybody? Yep. After. What do you mean after? Wait, let's just, if you use definition, you're going to answer your own question if you know what the fraction or percentage means. Does that make sense what I'm saying? So like, we said that there's some number here. Okay. This number I said is P25. Does that make sense? So wait, what did we say percentile meant? What was the definition we just said before that she said? The percentage or fraction less than. Does that make sense? So the percentage or fraction less than. So then what would have to be over here? 25%. Is that correct? Why would the section to the right be quarter one? No, but think about it. Like the first quarter, if you have like 0 cents here, right? 25 cents, 50 cents, 75 cents, $1. Does that make sense? But again, this dollar part is a little fishy. Okay. So then this, we can't, you could say this is the first quarter of the data set, right? But quartile one is larger than that. Does that make sense? Could be equal to the greatest number. Does that make sense? Does that make sense? So then, but to me here, it's like, oh, just split this like this. It's like, oh, the first quarter, second quarter, right? Does that make sense? So what's Q3, sorry? 79.5. Now this, if you typed in your calculator and you ran one more stats on it, would tell you what Q1, Q2, and Q3 are. But this is like, there's no way I'm typing all these stupid numbers in to do this. Does that make sense? All right. And this one here, you can't do it on your calculator. You have to know what the definition means. Does that make sense? So here, all we would say is 85 percentile, right? 85th percentile, excuse me, right? This means it needs to be greater than 85% of the data. Is that correct? Well, I need to know what the hell 85% of the data means first. Is that right? So that's what I do first. 85% of the sample size needs to be less than P85, my number. Does that make sense what I'm saying? Does that make sense what I'm saying? So if I figure out where 85% of the numbers are, right? Then it's the next number. Does that make sense? All right. But you got to be careful. So we'll see right now. All right. 85%. So how do I find out what 85% of the numbers are? How do I do that? We talked about this before. How do you do percent of something? 0.85. The first we write is 0.85. What does of mean again? Five sets of 6. Multiply. Does that make sense what I'm saying? You gotta remember this. I'm telling you. You're gonna get handled in the stores when the cashier sits there and doesn't calculate everything correctly. Do you know how much money people give me for free because they get scared because I'm just start calculating stuff and I'm like, this is the answer? I'm not kidding. You know how many times people try and screw me over? And I'm like, yo, I calculated it. It's not right. You got to give me more money. Seriously. It's 20% off. It's 30% off. It's 35% off. All at the same time. How much does it cost, right? Can you do it? Because you better be able to. Because this is all you need to do. 25% off. 35% off. Let's say another 20% off. Okay? If you're 25% off, that means you have 75% remaining. Is that correct? If you have 35% off, you have 65% remaining. If you have 20% off, that means you have 80% remaining. Is that right? So you just multiply these numbers. Because 75% of 65% of 80% means just multiply. Of means multiply. Is that correct? So if you got 25, 35, and 20 off, someone's going to turn around to me and sit there and tell me 25 plus 35 is 60. 60 plus 20 is 80. They'll tell me if the original item was $100, it's supposed to be now 20. If the original item is $100, the amount that you should be paying is $39. That's a big difference. Does that understand what I'm saying? But if I go to the store and the guy's ringing it up like this, I ain't going to tell them. And then you know what happens? They got to pay the $19. Does that understand what I'm saying? All right, 85. So you need to be able to do percent of something. Great. You have to remember of means multiply. Big deal. Does that make sense? So 85% of 40. Oh, wait. 85 is the same thing as 17 out of 20 times 40. 40 cancels, you get 2. So this is 30. Oh, does everybody see that? Now, the only thing you need to remember is if you have a data set and you have x1, x2, x3, x4, x5, x6, blah, 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 xn, right? Where xn is the largest number, and these are all less than or equal to the next one. Does that make sense? The numbers that I'm allowed to select as the answer for the median or for the percentile or for the quartile or anything like that are any of the numbers in the data set, but I can also pick the numbers between. Is that correct? Does that make sense? Right? Like we got 55.5 and 69.5. These weren't in the data set. Is that correct? I call this number right here x1.5. I call this number x2.5. I call this number x3.5. I call this number x4.5, etc. Does that make sense? All right. So P85 means 85% of the numbers need to be less than me. That means 34 numbers need to be less than me. So where's 34? 30, 1, 2, 3, 4, I guess. Is that correct? So what's the answer? Nope. Doesn't satisfy the definition. If you think about the definition. What's the answer? Nope. Nope. 83 is a bad answer. 89 is slightly better than 85, but it's still wrong technically. It's not the best answer we could pick. The answer must be 87. The midpoint between 85 and 89. Why? Because if I say that 34 numbers are 85%, right? Right? Her answer was a little better than yours because she was saying it needs to be larger than that. Does that make sense what I'm saying? We need to have 34 less than me. Does that make sense? But I don't have to go all the way. So if I need 34 less than me, there are these choices nearby. Does that make sense? If I pick the 34th number, though, I don't have 34 numbers less than me. Is that right? So I can't pick this one. Definitely can't pick this one. Does that make sense? This would be the first number I could select that would have 34 numbers less than. Does that make sense? So you pretty much just round up to the nearest 0.5. Does that make sense? If the answer ends up being like 34.2, I'd round to 34.5. If the answer here was 34.7, I'll round to 35. Does that make sense? Does that make sense? Or just think about it the way I just said it here. Any question? You get why I'm saying it has to be 87 here? Does that make sense, guys? So here's another reason why, though. Let's say we pick your number, and then we're done. All right. Let's say we pick your number, 85. How many numbers less than 85? 33, right? Right. So then, well, you can't because it's the less than thing, right? So then so 33 divided by, what is it? 40, right? That's not 85%. Does that make sense what I'm saying? You understand what I'm saying? Let's say you don't count. Let's say you say that instead there's one number here also. So it's 33.5 numbers. Does that make sense? 33.5 divided by 40 is this. Again, not 85. Does that make sense? But if I pick this number here, 87, it has 34 less than it. 34 divided by 40 gives us the correct answer. Does that make sense? All right, that is all. Thank you. Don't forget about your test and your quiz. It is due soon. I did put an announcement on D2L though. All right.